do k-means clustering, you need to have decided how many clusters you're looking for. So how many clusters should you look for? There is no one answer to that. I tried to emphasize that earlier. I'm afraid my lesson might just have sounded a little garbled. So let's try again. Suppose you have as your data set the measurement of animal bones, and you decide that you are going to use k-means clustering. How many clusters might you want? Well, the truth is there are a bunch of answers to that question. 5 might be a natural answer because animals are traditionally divided into 5 groups: mammals, birds, fish, reptiles, amphibians. And maybe you think that grouping will show up in the data set. Then again, maybe there isn't much difference between, a reptile bone and a mammal bone. I don't know. Maybe, it's a little banal, but maybe you just want to divide your animals into small, medium, or large. And if you want to do that, maybe you just need 3 clusters. Or maybe you know that how many, maybe you know like all of the species in this set of bones, and you know that in this set of bones there are 130 different orders of animals represented. And maybe you look for 130 clusters representing the order of the animals. Or maybe you end up with 4 clusters, and those 4 clusters have no clear real world meaning, but are very tight. So it doesn't clearly correspond to anything, but the clustering's really good. So the question of how many clusters should I select, is kind of ill-posed on the face of it, because the answer is, I don't know, what are you trying to do? What are you looking for? However, we can still approach the question, and we'll approach it from the point of view that we have no intuition of how many clusters we want. So without any intuition, all of these ideas go away, and we're just trying to find the best clustering number that we can find, whatever that means. There are a few methods we could use here. In this video, I'm going to introduce the elbow method, which is going to look really familiar because it looks really similar to principal component analysis when we created scree plots. Each principal component, remember, explained less than the previous one. So plotting principal component versus explained variance created a decreasing graph. And these graphs initially decreased slope quickly, but then they leveled out. And we estimated the number of dimensions to use by looking for the elbow of the plot. How similar is this to that? Well, it has the word elbow right there in it. This is the elbow method. Increasing the number of clusters makes the clustering better. You can read my Canvas section for details and definitions, but essentially, well, I should probably comment a little on this. Suppose you have 5,000 points, and you're trying to divide these observations into clusters, and you want to minimize the sum of least squares errors. Well, you know how to minimize the sum of least squares errors? 5,000 clusters. Every point goes in a cluster. The sum of least squares errors is 0. So in terms of this thing that you're trying to minimize, you can always do better if you just increase the number of clusters. So the word minimize is a slight misnomer here. We're not just trying to minimize something, we're trying to do something else as well. But increasing the number of clusters will always decrease the inertia, which is just a way of saying it will always decrease the error. So if we plot the number of clusters versus the error, we get a decreasing graph. And this graph decreases quickly, and then it decreases slowly. So what did we do with PCA? We looked for the elbow. No great prize for guessing what we do with the elbow method. We look for the elbow. And the code is all in Canvas. So I'm not going to comment on this in detail. We can create elbow plots easily using the various tools of sklearn and other libraries. I'll do it. So this is still the Penguin data set. I run this code, I get the elbow plot. And the elbow, it's ambiguous. And this was true of scree plots as well, right? It looks like maybe 3, but 2 looks viable as well. I'd say just from this that we probably want 2 or 3 clusters. And again, this is assuming that we don't have some kind of pre-existent intuition that we're working with. If this is all we have to work with, we probably want 2 or 3 clusters. And that is the elbow method.